Cool. Hi. My name's Roose. I work on Arc at a company called Second, and the original design of Arc was based on the existence of CTV, but the Arc that we're building doesn't use CTV, and that sparked, of course, a lot of questions from people like, so do you actually need it then or not? Let's see if we can answer that question. This is not working. Yes. Okay. So yeah, this is who I am. I also created this website at some point, governance.info, because there was a lot of proposals out there. There was a lot of potential use cases out there. I kind of did some effort in bundling those into like a nice list of use cases and proposals and like crossover. So yeah, you can check that out. So a quick summary of Arc. Who knows what Arc is? Who understands how it works? Cool. Maybe after this talk you will. I did other talks about Arc that are quite broad, but this talk I want to focus on a specific point, which is the core of Arc, and you will hopefully understand it afterwards. But from a higher level, what is it? It's kind of a new layer 2 protocol, similar to Lightning. It's non-custodial, so users always have unilateral exit. As opposed to Lightning, it's not peer-to-peer, it's a client server, but the server never has custody over the funds. So the users always have a way to go on chain and claim their money back if the server becomes non-cooperative. It's based on shared UTXOs with larger groups than two, so it's not based on channels. And you're basically exchanging small shares in a larger UTXO, and those shares, we call them virtual UTXOs or VTXOs, because they are UTXOs you could get on chain if you would use your unilateral exit. But as long as the protocol works fine, you never have to do that. Interestingly, it's quite interoperable with Lightning. So you can actually build channels inside your Arc. You can also make payments directly on the Lightning network from your Arc without needing to trust the server. And the main benefit is that there is no channel or liquidity management needed from the user side. So the server takes care of that in a trustless way. So the user experience and the developer experience for this protocol could be a big improvement over Lightning. So how does it work, right? I'm going to first explain the model that we're building, which is sometimes called CLARK, like covenantless Arc, which is the version without covenants. So this is what we call like an Arc tree, a VTXO tree. And you can think of everything above the line is like committed on the chain, and everything below the line is off chain, and hopefully we'll never have to broadcast this. So the way it works is you basically have people who own some money in this shared VTXO. They all have each 1 Bitcoin, just to make it easy. Alice, Bob, Carol, and Dave. And basically the root has all the Bitcoin, and then it has a large multisig with all the people below it, plus S, which is the server. And then you're going to break this down into like a tree shape, where eventually at the leaf, you just have one person getting their money back. But since their key is included in all of the multisigs above it, as long as they never sign an alternative spend path, they have a guarantee that they can actually get this money on chain if they need to. These are all like N of N, right? So 100% needs to sign. So as long as Alice, I don't have a laser, right? As long as Alice never signs any of the other transactions in a different way, she knows that she can always use these transactions, which are pre-signed, right? They have signatures already on them to get her money back. So this is what we will call a VTXO, right? So this bundle that Alice has, which is a set of pre-signed transactions that she can always broadcast if she wants to get her output on the chain, is what we will call a VTXO. So let's get out the part that we don't need. A cool little thing you can do in Arc to make a payment to someone else. Let's say Alice wants to pay Eve. She could just, another thing to mention. The way this works is because there is an expiry time on the VTXO, right? So at a certain height, this thing will be spendable by the server, and the user is responsible to make sure that they swap their VTXOs for new ones before this timeout, or spend it and send it to someone else. So how do you send them to someone else? You can actually just attach an additional transaction to this chain, right? So Alice can send to Eve. She can make a transaction. She uses the path there where she has to co-sign with the server. So she tells the server, hey, I want to send this money to Eve. Here's my signature. The server also signs it. And then there's an additional transaction that now she can give to Eve, which has the same structure as the previous one. So now actually Eve has a VTXO that she can always broadcast if she wants to. And Alice cannot take the money from her because for Alice to do the unilateral exit, she would have to wait. And in that time, Eve has time to broadcast her transaction. There's a small caveat on the R core VTXO. As you can see, if Alice colludes with the server, she could actually try to double spend this. So then Eve has the choice whether to trust this model that the server will not collude with the previous owner of the VTXO, or what she can do is she can swap her R core VTXO for a new normal VTXO. And that's what we're going to look at today, how this swapping mechanism works. So let's say there's two users, Eve and Fred, they each have VTXO and they want to swap them for a new VTXO. These are totally different trees, right? So they existed at different times in different points in time. And every so often, the server is going to coordinate a round and then create a new tree. And people from the previous trees can just participate in this route if they want to. Not everyone has to, if they want to swap some of their VTXOs for other ones. So there's 3 stages to a Clark round. In the first round, users are going to submit the inputs that they want to spend. So even Fred are going to say, hey, I want to spend my VTXO. And then the server will create an unsigned VTXO tree. So it will create a new tree like this. You can see that all the signatures are blank. And it's going to basically create a new VTXO with a new expiry time for Eve and Fred. So obviously, the signatures are not there. So what the users will have to do, they will first have to co-sign all these multisigs in this tree so that the transactions become valid and become an actual valid unilateral exit. So the users will send their partial signatures, right? It will fill those 3 boxes there on the bottom. And then this becomes a valid UTXO tree. This only validates the exit paths from the root, but the root is still not valid because it still doesn't have a signature. So this the money still doesn't exist. So the server will eventually sign this input to actually create and validate and create a valid tree. But obviously, if the server does it now, he's just giving free money to Eve and Fred because the original money is also still valid. So what we want to do is we want the inputs to be invalidated first. So we want Eve and Fred to sign a transaction that actually gives their old money to the server, right? But Eve and Fred obviously also don't want to do this first because then they are giving all their money and they have no guarantee that they will actually get new money. So the core of Arc is actually making this swap atomic and trustless. And it's actually not really hard how to do that. What you can do is you can have an additional output on the new round and use that as an input for your forfeit transaction, right? And then Fred can safely sign this forfeit transaction because he knows that he's only giving his money away to the server if he has a guarantee, if this input exists. And if that input exists, he knows that he has his new VTXO, right? So it's safe for Fred to sign this input because it has this connector output, like we call it. It has this connector input that has a cryptographic guarantee that it's only valid if the new VTXO that Fred wants is on the chain. Now we have multiple inputs, right? In this example, we have 2, but we can have any number. So to optimize that, we can just create another chain of transactions or a tree of transactions to basically provide connectors for all the different inputs. So this is basically the core of Arc. So once this has happened, users sign their tree. After the users have signed the VTXO tree, the server then creates this signed tree, sends it to everyone. Users sign their connectors. And then in the last step, users sign their forfeit transactions using their connectors. So they will sign this. And then in the very last step, the user can sign the root transaction because now it's safe for the user, for the server to actually give the money to the users because the server knows that if any of the users is trying to claim their money on both sides, they can actually confiscate one of the sides so that it doesn't get cheated out of their money. So we can sign this, and this is a successful Clark round. So there's a big problem here. I want to show this. So there's a big problem here because we do this whole process, and at some point, Eve can just decide to either drop out because the computer died, has no network connection, or because they are malicious. And if Eve decides to not sign their forfeit transaction, the whole process needs to start again. The server needs to cut out Eve from the set of people that want to make a transaction, and then they have to sign the whole tree again, they have to sign their forfeits again, And if an attacker could like participate in this round with 100 different inputs, he can actually cause a round to have to restart 100 different times. And if people are on mobile phones, this can actually take minutes up to like multiple hours to actually succeed. And this is a really big problem. So CTV partly solves this problem in the original design, like it was proposed by Burak, because in this example, when we would use covenants, we wouldn't have to sign the VTXO tree, right? So if we use covenants, we can actually immediately create this tree because the covenant actually commits to the next transaction. So we don't need the signatures on those trees anymore. The covenant guarantees that the only way to spend this money is to create the transactions below it, and then the server can just calculate the covenant and then guarantee that even Fred will have this money. So then the protocol becomes a two-step protocol. We do the same thing with the connectors, but there's only two steps. First, the users submit their inputs, and then the users can immediately sign the forfeit transactions as soon as they receive the tree from the server. The users don't have to co-sign the tree anymore. The server can just create it and send it alongside with the connectors. So then after the users have signed their forfeit transactions, like this, the server can freely sign the input. But there's still a denial of service risk, right? Because what if the users don't sign their forfeit transactions? You still have to restart the rounds and re-sign your forfeit transactions. Luckily, this is only a single transaction per input and not like log n of all the users. So like it's significantly reduced in the amount of things users need to do and the amount of bandwidth we need to send around to all these users. But there's still a potential problem. So recently, my co-founder had an idea where we could actually cut out the last round of interaction as well. So in this case, the ARC round would become totally non-interactive, and we would only need a single like thing. The user would just tell the server what they want to do, and at some point the server can just bundle all these requests that it's gotten and immediately make a round and send it to the users, and then all the other interactions can happen asynchronously afterwards. So how does this work? I called it ERC because it was invented by Eric, but we can definitely bike shed better names, something like NARC for non-interactive ARC or ARC-v3 or whatever. So let's look into how this works. We're gonna first change the original ARC design by introducing again a multisig, but only on the very last hop before the VTXO. So this is always just one user with the server, right? And all the things above that still stay covenants. And then when the server actually receives the request from the user, so Alice and Fred want to do a swap, and the server can immediately create this tree, but it doesn't sign the last hops. So since it doesn't sign the last hops, when this transaction broadcasts, Alice, even Fred don't receive any money yet, right? So they still only have the money on this side. So it's actually safe for the server to immediately sign this and broadcast this. And then at a later point in time, even Fred can come online and actually do a process that is only between them and the server, so no interaction with other users, to actually claim the signature to unlock their new VTXO. Now, obviously, this needs to be atomic as well, but what we can do to do this is have them sign what we call a refund transaction, which is actually a transaction that takes both of the different versions of the VTXO, spends them both, and then gives one to the user and one to the server. And this is obviously fair, right? Because the user only has one Bitcoin and doesn't have two. So like in any case, if the user tries to exit this one instead of that one, the server can use this to make sure that the server can use this to make sure that the server doesn't have the money on both sides. And this is great because Eve can just come online, tell the server like, hey, I signed up for the round and it seems that you did it. How do I get my new VTXO? The server says, here's the refund transaction, and the user can just provide all the partial signatures for this. And then the server can give him the signature for this in return. Now, what if the server doesn't do this? Then the user will have to do a unilateral exit on the side, and then they still have their money, right? The user always has to do a unilateral exit if the server is not cooperative. So there's nothing different here. And by signing it, the user never loses anything. It never risks any money, because the worst thing that can happen is that the server uses this to activate the refund transaction, but it still gives an equal amount of money to Eve. So Fred does the same thing, and our round is done, and we only had like a single round of interaction. Now, it seems that this only works for one input and one output, right? We can easily optimize that and like make it work with multiple inputs. In a naive way, you would think, okay, we can just have multiple inputs on the refund transaction. This is kind of broken because now, if let's say there's several inputs and the user is acting maliciously and broadcasts one of its exits, now the server has to broadcast multiple of these trees in order to rectify the situation. So the user can actually cause a big cost on the server, but we can do a neat little trick again and introduce another intermediate transaction to basically break up the new output again, and then have one refund per input. And then it works with only the cost of one additional transaction. Cool. So this is ERC. It's fully asynchronous, right? So it's pretty cool. Users just sign up for rounds, and the server just decide at a certain moment that the round is done. There's no waiting for other people, and there's no potential denial of service issue. And for us at Second, we're heavily focusing on trying to make this work for mobile clients and actual wallets for normal spending wallets. And mobile is really hard. Especially iOS, interactions and things that last more than 5 seconds are really hard to do in the background, right? And for Arc, like I said, your VTXOs have an expiry time. So at some point, you just need to come online, do this round thing to make sure you don't lose your money. And it would really suck if you would have to wake up the user to say, hey, look at your phone for like half an hour, otherwise you're going to lose your money. And that's what it might look like in the current situation on iOS. With Android, you have a little bit more flexibility to run stuff in the background. But we're not very optimistic on how this protocol will work on mobile. We're still working on it. It's our priority. But with this different protocol, it looks a lot more positive. So what other things do we get from CTV, right? This is for me like the biggest benefit from CTV for Arc, but there's some other ones. First of all, direct user to user in-round payments. Right now, you can only send, like I said, out of round because the receiver needs to be online in the current situation with Clark to sign this like VTXO tree, and that's kind of unfortunate. So like when you can have pre-generated trees with CTV, the user can just say, I want to send and create a new VTXO for another user, and then it can just be created using the CTV construction. Like I said, you can do lightning stuff from Arc. Sending is very trivial. Receiving is a lot more complicated. We're working on a version right now. It's not super optimal. It would be a lot nicer with CTV because then the server can just create a simple HTLC in the VTXO tree and then give it to the user after the user gives them the pre-image. Right now, we have to do some weird stuff where the server creates it and then deletes the key and promises certain kinds of stuff, and it might not be very nice. Another thing that I'm personally quite excited about is like mass payouts. If your tree is pre-generated using covenants, the only thing you kind of need to create an entire tree like this is the pub keys of the user and the pub key of S, right? Like all the information here is just the pub keys of the user and the pub key of S. And where those 4 Bitcoin come from don't really matter. So the server usually provides this money, but someone else could actually provide this money. An exchange who wants to pay out their users to an ARC can just non-interactively create an ARC-compatible output that creates a bunch of VTXOs and just fund it. And then tell the users like, hey, your money's here. You wanted an ARC output. I created it for you. And that's kind of powerful. It could also be a mining pool. And it could also be like a decentralized mining pool, which existed in the past, but had some problems because to pay out small amounts to users, you would have to create a really high amount of outputs. But with this sort of construction, you would only have to make a single output and you could pay out a lot of smaller value payments. And the last thing I think that you can also do with CTV is do like reissuance, right? Like I said, your VTXO expires after a certain time. We're thinking about like 30 days, maybe a bit more because it's a bit nicer for the user. But if a user just doesn't show up within 30 days, in theory, the money is kind of accessible by the server. And like we at our company obviously don't want that. So what we're planning to do is just immediately create a new VTXO for the one that was not redeemed, and then the user kind of immediately has it again. This is kind of trusted, but the server can quite trivially prove that it always did this correctly and never actually confiscated money. And I kind of like that model where like you can continuously request the server to prove that it's been honest for like its entire operation, and that can give you some kind of trust into the server doing it in the future as well. But without CTV, it's not really possible because you cannot create a VTXO for someone else. That's kind of the root problem. So in the current scheme, it would be kind of weird again to do it with like creating it and then telling someone that you deleted the key. Yeah, with CTV, it would be possible. And the holy grail would obviously be that somehow the server can trustlessly reissue and use some kind of script path that actually allows them to take the money and reissue it immediately if it goes back to the same user. That's not possible with CTV, but it would definitely need CTV to eventually be possible. So, do we need CTV? I'm not going to say we need it, but I think I made some convincing points that it would be very nice for us to have. And yeah, that's kind of the point I wanted to make. Is there questions? The slides are available on roose.io, and you can find our implementation, our documentation on the implementation, and some protocol documentation through second.tech, our company's website. Thank you. Sorry if I went too fast. We can definitely go back.
Just a quick question. In terms of the Covenant implementation, most of it seems to be focusing around the transaction outputs, enforcing those. Are there any potential benefits and also like enforcing the transaction inputs, like the specific UTXOs, like that?
Are you talking about just Covenant construction in general, or something Arc related?
Well, just with respect to Arc, right? Like, are there any benefits or potential benefits in enforcing the actual inputs here? Because it seems that you could fund it from anywhere, right?
You mean at the top or in the middle?
At the top, in the middle, at the end.
Well, funding new things from anywhere just makes a different tree, right? Usually, I mean, I don't think what you're saying kind of makes much sense to do. You wouldn't enforce the input, like.
So basically, there's not much benefit into enforcing the inputs themselves.
I don't know what you mean with enforcing the inputs. Like the input obviously is there, the money comes from somewhere, and you want to enforce something on what happens with the money. Like something maybe useful is enforcing sibling inputs. That's what the BitVM trick is that I'm sure someone else will talk about and has been mentioned before. It's like if you have two inputs, you want to say I'm only valid if the other input's also here. That's something else that you can, in a very ugly way, do with CTV. Coming soon. But no, for us, it's not useful. We're basically just breaking up a bigger thing into smaller things. So it's always going to be one in and then multiple outs. We're actually using 4 out. This is a binary tree because we're all used to that and they're easier to look at. But we're using 4 because it's just optimal. It's just smaller exit branches. But yeah, that's just a design optimization.
Exciting stuff. I'm really curious on roadmap in terms of what you think in terms of the mobile client being ready and any sort of predictions on, like, will this be ready for, end of year, October? Like, what you think?
We're thinking 2 weeks. No, that's a good question. We recently released our clients on Signet with a little store and a little faucet, so you can withdraw some Arc money from the faucet, some VTXOs, but also some on-chain money from the faucet on Signet, and then you can make Lightning payments to like a little store through the Arc. So that's fun, but we're still like realizing that some things are not working really perfectly. So yeah, we're definitely not near mainnet, but we're getting through the phase where we want to start integrating with mobile clients, because our client is just a Rust API and then a CLI based on that. So you can play around in your terminal. If you're a Rust application, you can already use it. Our faucet is actually like built on top of the same thing. But yeah, so from here on, we're gonna start trying to partner with some mobile wallets that are willing to integrate it. We have some people that we're talking with that are quite excited about this. And then we're gonna have to learn from there. It's probably gonna work a lot faster on Android than on iOS. I don't know how far we're gonna get with iOS. We can do all kinds of things like breaking up the run process into like multiple small interactions, maybe having a special flag that says, "Hey, I'm iOS. Be a little bit more lenient on me," and then you have less different options to participate. But if you drop out, you're not punished as much. Yeah, I'm not a mobile developer, so like I only hear horror stories about iOS. But I mean, they're confirmed by many other people's horror stories. So I'm definitely curious. I think we can provide some decent user experience, definitely on Android. I don't think it will be too bad. But for iOS, we're still yet to see. I mean, it will all depend a lot on how much users are there, right? If the runs are small, it's probably going to be fine. If there's no one actually being malicious, it's also probably going to be fine. But like this is Bitcoin, you kind of have to plan for the fact. Like you cannot say, "Oh yeah, sorry, it doesn't work because someone else is making a lot of transactions or someone else is being a bit annoying." So yeah, we want to make it as robust as possible. And let's see, maybe end of year, something like that. I mean, maybe sooner we can have something Signet on mobile where you can like try it out, but mainnet, yeah, I would shoot for end of year or something like that. Yeah, we're planning on going there. More questions?
Yeah. Have you thought about just ignoring mobile for like a few years? Just build software that people can transact more money on desktop or servers?
No. I mean, if you have a server, use Lightning, I guess.
Lightning sucks. So like
Lightning sucks. I mean, yeah. No, I mean we want to focus on Lightning on mobile because we think like most users, like actual transactors, like end users, are using Lightning, so are using mobile. So yeah, we want to get them. We want to give them like a Lightning experience on mobile that is for them seamless.
but that's not true. I mean, most money is not on mobile, right? Like the largest client that does Lightning did probably like 1.5 million transactions on Lightning. That's on Noster, and those are like super tiny transactions, right?
Yeah, and they're also custodial.
Yeah, sure, exactly, right. So why not let people say, for example, do payroll or do other kinds of transactions on desktop and leverage this? Because like this beautiful privacy right here.
Well, two parts. One part is maybe people are not using it on mobile because it sucks. We never know. We're definitely not like we're gonna focus a lot of our energy on making this work on mobile, but that does not discount that it will not also work on desktop. Like this is a Rust API for now, so anyone building with Rust can build this on desktop whenever they want. There's a CLI as well that anyone who can like wrap a CLI can use to build the application using the CLI. We're going to create other bindings, but we just don't want to like create them all at once and do all the work to like get them all right. We're going to probably pick one depending on who wants to integrate with us first, and then focus on those bindings and then extend to different bindings. But like definitely any desktop application that wants to use this can immediately like also use this or create their own bindings or just build in Rust or.
Are you talking to the guys from Harbor?
Harbor?
Yeah.
No.
Future Paul.
Okay, I heard that name.
They're working on making desktop clients for some of the swaps for privacy.
Mm-hmm.
And okay. They some of those the issues that there's no liquidity on Cashew, like to do anything of any meaningful economic value. So this seems to fix some of those problems.
Yeah, I mean, the reason we focus on mobile is because we think it might not work, right? I think on desktop it will just work. So like if we're making it try to work on mobile, we will probably be at a point that it already works on desktop. So they can just either use the Rust API or like request bindings or do bindings themselves. It should just work for them. You talked about privacy. That's an interesting thing, actually. The private version of Arc also doesn't work without CTV. I didn't want to put it on my slides, but recent changes of US policy might have allowed me to do that. No, I mean, the private version doesn't work with CTV. We're not sure if the private version works with ERC, with the new design, because it kind of like intrinsically links the input and the output. So it's kind of like, how are we making this private? We're going to do some thinking of that. Something I still wanted to say, we're planning to formalize this in the next week or two. It's still very new. Like this, we only thought about this 2 or 3 weeks ago. We've been like talking with some people to see if it would work or not, but it seems to work. So like we're gonna probably write this out, see what the actual benefits are, what the drawbacks might be related to, for example, privacy. There's also something where it's hard to build our core chains on the new output because you suddenly could end up in two states, either the normal one or the refund one. But it seems that with checksec from stack, you could actually use the same L2 trick and have rebindable signatures, so you can build on both chains at the same time. So that could solve that problem. And at some point, once the input is expired, you can basically drop the whole refund construction, and then you can just do a normal stuff like that. But yeah, to answer your question, I think desktop will just work as soon as we're trying to make mobile work better. Because we're not in the business to try and build an app, try and build a wallet. We want to build the infrastructure, the SDK, and the tools for people to use this to build wallets.
I noticed you talked about P2 pool. Have you looked at the work that Jungly has done to reboot P2 pool? In particular, he's bringing in some ideas from Braid pool that would allow miners to trade shares before the Coinbase reward is awarded. And I was looking at the graph in particular, and it struck me that it's just ARC in reverse. So instead of having liquidity funneled into the inputs of the transactions, you have mining pool shares as inputs, and you can trade these things virtually, and you have liquidity emitted as outputs of the transactions. It seems like some surprising parallels. So if you haven't talked to him, definitely,
but these
you guys should get together. Okay.
These are like then transactions in the pool chain, right? Not on the Bitcoin chain. Yeah. Okay.
Right. If you're mining mining pool share, you're committed to a Coinbase output. So you can kind of treat that Coinbase output as a VTXO of sorts. It doesn't have an appropriate difficulty level, but you're entitled to some share of the mining pool reward.
I think someone talked to me about this also yesterday. What was the name of the person I should talk with?
Jungly. Let's talk more.
Yeah, cheers. Yeah, I definitely think it's a valuable exercise to try and revive things like Pool, just to like make decentralized mining a little bit better. Cool. Yeah, thanks. I don't know if there's a...
I would love to do another question, but we have to stay on schedule and go to a break. Thank you so much, Steven. Let's hear it for Steven.